Now, let's look at this. We have a solution. Let's read the question. We have a body of mass 5 kg falls on a height of 10 meters above the ground. What is the kinetic energy of the body just before it strikes the ground? Neglect energy losses and take G equals 10 meters per second squared. This is Waec 1992. Now, we have our parameters given. Let's bring them out first. A body of mass, so we have mass, which is M, is the same thing as 5 kg. Falls on a height, so also have height, which is H, is also the same thing as, if you're given as 10 meters above the ground. What is the kinetic energy? So we have kinetic energy, which we can use KE, is question mark. So they said kinetic energy. What is the kinetic energy of the body just before it strikes the ground? So neglect energy losses and take G. So we have G, which is given as 10 meters per second squared, and the G is gravitational force, the acceleration due to gravity, our G here. So, and then we asked to look for kinetic energy. Now, the formula for kinetic energy is Ke, which we said stands for kinetic energy, is equal to 1/2 times mass times velocity. Now, the velocity is squared, which is still the same thing as Ke is the same thing as 1/2 times m times v squared. Now, but if you look at this question, we don't have v given to us. We will have the mass given here. Mass is given, but we don't have v. So therefore, it means we can get our v. Now, if you remember the equations of motion based on linear acceleration, based on linear motion rather, we will have this based on linear motion, that's still under acceleration, velocity, and even speed. So we have this. If you want to calculate linear acceleration, we have equations of motions that we use. We have v. The first one is v equals u plus at. The equations of motion, we also have another equation that says that v squared is, let's have s first. S is equals to ut plus 1/2 at squared. This is also another equation of motion. We also have another one that says that v squared equals to u squared plus 2as. Now, anytime you are asked to look for v is the final velocity, and then u is initial velocity, a is acceleration, and t is our time. So the same things we have here. Now, s here stands for distance, which is represented as s. Now, if you look at these questions, if we're looking for our v squared, if we use this equation, we don't have time. There's no time here. So we have to look for time, and that will take our time. We also have s, so we cannot use it just what we said because we have t given here. So we can equally use this. V squared is equal to u squared plus 2as. So that since we know our s, we will take this g as a as g, because that's what we have here, g. We have this motion is based on, it's a vertical motion, it's not a horizontal motion. So we have a body of mass 5 kg falls on a height of 10 meters above the ground. So on a height, vertical motion. So to look for our v squared, I'm going to be using this. So using v squared equals to u squared plus 2. Now we replace this with g and we replace this with h, since we're referring to gravity here. So we have v squared is equal to, now if you look at this, we don't have u given here, but look at it, a body of mass 5 kg falls on a height of 10 meters above the ground. So here we're going to be taking our u to be 0, because we assume that the initial velocity, a body of mass 5 kg falls on a height, we believe that it was at rest before it started falling. So u here is going to be 0. So we have u squared plus 2 times our g is given as 10 times our h, which we have here as 10 meters. So we're going to have v squared is the same thing as this 0 squared, it doesn't exist anymore. 2 times this, this is 10 times 10, it's 100. 100 times 2, we have 200. So we have 200 meters per second. Now I've gotten our v squared. There's no need of looking for the square root of this number, because what we're even looking for is v squared. So we'll come back here, putting it here. So let's call this one equation 1. So let's call this asterisk. So we can say, or let me call it, let's call it equation 2. So we can say putting v squared, 200 meters per second for v squared in equation 1, or equation 1. In equation 1, we have, so let's finish it up here. We have Ke is the same thing as 1/2 times mass. Mass is 5 times our v squared. So no more writing v squared, we'll just write 200. It's 200. So Ke is the same thing as, we divide, it's like over 1/1. So 2 here, 1, 2 into 200 is 100. So when we multiply, I'm going to be having 500 as our answer, but there's a unit for energy. Energy is measured in joules, so 500 joules. This is our answer. Thank you for watching, and do not forget to subscribe, to like, and to share our videos.